We have to starting with the topic that is the basics architecture. Okay, basic architecture means we should have to cover about in this regarding the two architectures. First is now von Neumann architecture that should be invented by the John von Neumann. Then second architecture I have to discuss about with you regarding that is a Harvard architecture. Okay, so PPT is shared with all of you. That will be I have to share the PPT starting with the von Neumann architecture. Okay, according to the von Neumann architecture, I have draw the some diagram in your board. Okay, so that is a diagram I have to describe in your board also. That is the von Neumann architecture. This is a basically diagram. Board, the board is visible to all of you.
Yes, sir.
This is the now basic diagram of the von Neumann architecture. Okay, so what is a von Neumann architecture? Von Neumann architecture is simply that should be the release according to the first architecture in here. That should be the include here some CPU control units, including your control units, arithmetical and logical units. Okay, with your memory unit, and externally you have to give your input device and the output device is connected with them. Okay, according to your von Neumann, in von Neumann architecture, the same memory and the buses are used to store both data and instruction that runs the program. Means the same memory and the bus are used to store both data instruction that run the program. Since you cannot access the program memory and data memory simultaneously, means you cannot access your program memory and the data memory simultaneously because only single bus is used in that. The von Neumann architecture is susceptible to bottlenecks and system performance is now affected. It has basically three basic components. Whatever I have studied, that is the input output interfacing, CPU and the memory unit. That should I have to explain in your PPT also. Okay, so that is a simplified block diagram of your von Neumann architecture. So because इसमें क्या है आपका जो आपकी एक सिंगल बस ही होती है, you have to elaborate with them. That is only one data bus which is used for the both instruction fetches and the data transfer from the memory, which is also used for storage for both instruction and the data. Data and instruction can pass in your half duplex mode to and from CPU. Okay, so that is the diagram including in the, this is a simplified diagonal representation of the von Neumann कि आपके बीच में इसका, that is a control unit, arithmetic logic unit. Okay, then there is a memory unit, and each and every only single bus is used for the data and the address. Means single bus is simultaneously आप program memory और data memory को use नहीं कर सकते because that is uses the single buses at a time. So that is the von Neumann architecture, which includes some basic component. There are some advantage and disadvantage of von Neumann according to your, with the help of your Harvard architecture. So that is the simplified von Neumann architecture. All of you having the clear about this one?
Yes, sir.
Yes. Sir, kindly repeat von Neumann architecture.
Next architecture, that is your Harvard architecture. So Harvard architecture stores machine instruction and data in separate memory units and that are connected by your different buses. So there are at least two memory address space to work with. So there is a memory register for machine instruction and another memory register for your data. Computer designed with the Harvard architecture are able to run a program and access data independently, therefore simultaneously. So Harvard architecture has a strict separation between the data and the code. Thus, the Harvard architecture is more complicated than your separate pipelines and remove the bottleneck that the non-human create. So, according to I have to draw the architecture of the Harvard architecture. So, I have to draw this architecture in the board. I have drawn the diagram of the Harvard architecture, that is a program memory. Okay, that is your CPU. That includes your instruction cache. Okay. That is your program memory address bus. That is your PM address bus. Then both sides, that is your program memory data bus. Then we are using your data memory with include your data address bus, that is your DM address bus, then your DM data bus, that will be including to the both side of this. Now it should have to for the data memory for the data only. Now we are using the input output controller in that. Input output controller. Okay, that should be include your data. So that is a simplified block diagram of your Harvard architecture. Previously, I have drawn the diagram of the von Neumann, and right now this is a diagram of the Harvard architecture from the basics criteria. Whenever the number of enhancement of the processors and the microcontroller architecture. तो previously we are using von Neumann. Von Neumann में मैंने आपको पीछे भी बताया है कि उसमें जो central processing unit that will include your memory, that is the arithmetic and logical unit with program memory and data memory share the same buses. That's not the only different buses to each other. So whenever you have to run your program memory and the data memory in that, you have to basically include Now students, I have to hello, I am audible to all of you?
Yes,
Yes,
sir.
sir.
Okay, okay. So there is some light problem. So that is I have to draw the Harvard architecture. जैसे मैंने पीछे बताया von Neumann architecture difference क्या था? That will be the program memory and the data memory. Program memory and the data memory means that will share the same buses. So that is the previous one architecture von Neumann, and this is the Harvard architecture. In that CPU that should be connected with the different buses, that is the address bus and the data bus with the program memory. And similarly, CPU instruction catching same buses, different buses you can connect with your data memory. Okay, so that is a different block you have to attach with a different one with the CPU, whatever your program memory, and then it is your data memory. And for the data memory is connected with the input output controller and the data. So in that case, that is the advantage of the Harvard architecture. In the case of your von Neumann, so means that will be the share the different buses. Means simultaneously you can access your program memory and your data memory. So that is the advantage of your using your Harvard architecture. Okay, so that is the some advantage of our architecture of the Harvard as behalf of the previous one architecture von Neumann. You can access the data and the program memory simultaneously at a time. Okay. Explain the Harvard architecture with the number of your system you have to involve in that. Mean that is your buses. Buses means buses are used as a single pathway in Harvard architecture. There are separate buses for the both instruction and the data. As per I have to explain the diagram in your board also. Okay, type of the buses means that should be the using your data bus. Data bus, what is data bus? It carries data among the main memory system, processor, and the input output devices. Similarly, second type of buses, that is your data address buses. Okay, data address buses, it carries the address of the data from processor to main memory system. Okay, so that should be the fall under the category of your Harvard architecture. Third one is now instruction buses. Okay, instruction buses, that will be, it carries instruction among the main memory system, processor, and the input output devices. Okay, so next one is now instruction address bus. It carries the address of the instruction from processor to the main memory. So there are the some different type of your buses I have to understand in that. So buses, that should be now data bus, address bus, and your instruction bus, instruction address bus. So there are four type of buses you are using in that. Okay, four in using in that. So that is the different buses that are separately used for the program memory and the data memory for that. Okay, so next one, there are some resistor include in that operational resistor first in case of your Harvard architecture. So there are different types of resistor involved in it, which are using for storing address of different type of instruction. For example, memory address resistor, that is known as here. We are using the different type of resistor, that is a memory address resistor. I have to read out this one. There are some resistor we will be involved in that. That resistor is now MAR. That should be known as here memory address resistor. Okay, now second one is now MDR. That both are your operational resistors. MDR is now memory data resistor. That under the fall category of your operational registers. Okay, so there are two registers we are using in that. MAR register, memory address register, and MDR, that is the memory data register, are the some operational registers. So next point including in that, in the Harvard architecture, that is your program counter. So that the topic is now including with the each and every microprocessor or the controller program counter. It has the location of the next instruction to be now executed. Program counter then passes the next address to memory address register. Means it will be execute. It will be moving to the next instruction to be executed. Program counter means function. मैं briefly आपको बता दूं. Program counter means it can execute the memory address for the next instruction to be executed. मान लो whatever one simple instruction is now executing according to your memory address. So program counter maintain the memory address to executing for the next instruction. Next instruction जो हमारी execute होनी है, उस instruction का जो memory address होगा वो program counter पे load होना चाहिए रहता है. So that should be meaning of your program counter. Next है आपका arithmetic and logical unit. Arithmetical and logic unit. उसके यहाँ पे I have to giving some. Now next one we have to starting with some your arithmetic and logical unit. Okay, arithmetic and logical unit. Arithmetic and logical unit is that part of the CPU that operates all the calculation needed. Calculation needed. It performs your addition, comparison, subtraction, shifting operation. मीन्स यहाँ पे आके सभी वो ऑपरेशन बिहेव करते हैं जस्ट लाइक योर ALU. ALU में क्या होता है बच्चे? इट शुड हैव यूजिंग योर सम रजिस्टर. रजिस्टर्स क्या होता है? एनीवन नो दैट व्हाट इज अ रजिस्टर्स? एनीवन नो दैट? आई हैव टू टेलिंग अबाउट द नंबर ऑफ टाइम रजिस्टर. व्हाट इज द मीनिंग ऑफ द रजिस्टर? हेलो हेलो.
Yes, sir.
Anyone know that what is? I am telling the number of time resistor. What is the meaning of resistor?
सर
Yeah, tell.
सर रजिस्टर जो होता है सर.
Wait. I have to telling about that is a resistor means that I have
सर
to
वो
storing the
information
some data in memory addresses. Whatever in your any. Wait. I am telling you. बता देता हूँ मैं, बाद में डिस्कस करेंगे. That means resistor means you have to storing the data some your memory addresses. मेमोरी एड्रेस का कोई ना कोई एड्रेस होगा, उस एड्रेस को हम एक रजिस्टर बोलते हैं. और ये रजिस्टर जो होते हैं it should be now variation with the help of the type of your microprocessor and the controller you have to use. Means resistor it may be of your microprocessor or controller having the 8-bit resistor, 16-bit resistor. So and majority of your, if you are using your 8085 microprocessor, so 8085 microprocessor you are using in that is your 8-bit, mostly 8-bit resistor. They have also a 16-bit resistor at a time, but वो mostly 8-bit के resistor होते हैं. तो उसी के बेस पे ना आपका जो arithmetic and logical unit operate करता है, that should be based on your accumulator. Accumulator is a type of resistor that should be having performing the arithmetical and the logical units. Every arithmetical performs addition, subtraction, comparison. Logical operation में क्या आ गए? That should be the logical one. And, or, gate, and gate, XOR gate, NOR gate, XOR gate. All the logical operation it should be also follow under the category of your ALU unit. Okay. So that should be the under the category of arithmetical and logical unit. Next one is now control unit. Control unit is the part of the CPU that operates all processor control signals. Processor controlling signals that will be controlled by the controller unit. It controls the input and output devices and also control the movement of instruction and data within the system. So that are the number of controlling one phenomenon, it should be handled by the control unit. It can operate your different processing signals. You have to controlling that one. Okay. Next one is now input and output system. That last component we are using in the Harvard architecture, that is your input and output system. Input and output system means input devices are used to read data into main memory with the help of CPU input instructions. The information from a computer as a output are given through output devices. So input output devices means you have to connectivity any interfacing units. Interfacing unit just like your A to D converter, D to quick converter, whatever you have said, your stepper motor, LCD. So that are the type of different type of your interfacing module you have attaching with them. So that are the some brief introduction of your basically von Neumann architecture and the Harvard architecture. I have to explaining with the block diagram von Neumann architecture and the Harvard architecture with the briefing the basic components and how it should be now differentiate architect between von Neumann and the Harvard architecture. So next topic, according to this one, I have to explain the difference between wait. Now the next slide, it should be based upon your, there should be the difference between your how the various point difference between your von Neumann and your Harvard architecture. Okay, तो क्या क्या difference है हमारे Harvard architecture में, क्या advantages है, क्या disadvantages है, von Neumann में कौन से advantages हैं और कौन से disadvantages हैं. That is your under the category of your advantage and disadvantages of your von Neumann architecture. Okay, I have to elaborate one by one. In the case of your von Neumann, not only advantages, I have discussed the first advantages, not only data but also instruction of the program are stored within the same memory. This make it easier to reprogram the memory. So that is the first advantage of the von Neumann. Neumann का advantage क्या है आपके लिए? The not only data but also instruction of the program are stored within the same memory. Means same memory में आपका data ही नहीं, आपका program में store हो रहा है. इससे क्या है? That will be easy to read memory. So other advantages, memory organization is within the hand of the programmer. Means memory organization is within the hand on the programmer. Third advantage is data from the memory and devices is accessed in the same way, because you are using the same bus, so that you using the same way you can access your data and the memory. The control unit gets data and instruction in the same way from one memory, so simplify the design and development of the control units. So that are the some advantages of your von Neumann architecture. So there are some points is also shown in your PPT also. In Asian computer architecture based on the stored program computer concepts, same physical memory address is used for instruction and the data. There is common bus for data and instruction transfer. 2 clock cycles are required to execute single instruction. It is cheaper in cost. So that are the some advantages of your von Neumann architecture. Okay. Now then I have to explain next one, that is the disadvantages of the von Neumann architecture. Disadvantage बता रहा हूं बच्चे. Now disadvantages, now it has only one data bus shared from the transfer of data transfer and the instruction fetches. They must be scheduled because they cannot run simultaneously. So that is a disadvantage, because that is the only bus and share the both data and the program memories, so it cannot be fetched on the same simultaneously time. Next one is now serial instruction. Serial instruction processing does not allow for the parallel execution of the program. Parallel execution must be simulated later by the operating system. Means there is no pipelining is available on the von Neumann. Pipelining means the number of instructions can run on the single cycle. The number of instruction cycle आपकी run हो रही है single cycle में decoding, fetching, execution, memory, read, write, that should be on the single cycle. So pipelining is not available in on the von Neumann architecture. Third disadvantage is higher chance of corruption or error as the instruction and data stored transferred in the same way, so that errors is higher chance in that in the case of your von Neumann. So that are the some advantages and disadvantages of the von Neumann architecture. Okay, so anyone having the doubt here, advantages and disadvantages of your von Neumann? Now the last one we have to discussion about the benefits and mean advantages and disadvantages of your Harvard architecture. So ये advantage disadvantage दोनों के difference भी हैं और benefits भी हैं. Now advantages of your Harvard architecture I have to explain. Firstly, there is less chance of error since data and instruction are transferred via different buses. Means the first advantage is क्या है आपका कि means यहाँ पे in case of your Harvard architecture there are different buses. So due to the different buses, data and the program memory faces your less error as compared to the same address bus, same bus if you are using. दोनों में जो है that you are using the different buses that make your less corruption of the data chances. Okay. Second one advantage is that data and instruction are assessed on the same way or it may be assessed simultaneously. That is the second advantage. Third one is now it offers higher performance because Harvard allow for simultaneously fetching of data and instructions. So they are kept in separate memory and travel via separate buses. So that is the third advantage. Fourth one is now both memory can use different cell sizes, make efficient use of resources. So similarly in the PPT also there are the some advantages and the difference of the Harvard architecture with the von Neumann. I have to explain in that. So that is in modern computer architecture based on where Harvard marked IRelay based model. Separate physical memory address is used for instruction and the data. Separate buses are used for transferring data and instructions, and instruction is executed in a single cycle. Previously, the von Neumann is now cheapest one. It should be architecture is now costly than your non-Neumann architecture. CPU can access instruction and read write at the same time due to the different buses you are using in that. It is also used in microcontroller and the digital signal processing. So that are the some advantages. If I am discussing about the disadvantages of the Harvard architecture, so now the first one is now when there is free data memory, it cannot be used for instruction and vice versa. Memory dedicated to each must be carefully balanced in your manufacturing. Second one, production of the computer with two buses is more expensive and take more time to manufacture. So that is a disadvantage. Means if you are advantages to manufacturing for the buses, that it will be expensive and take more time for the manufacturing effects. Third point is now Harvard architecture has more pin, so more complex for main board manufacturer to implement. So means the pins in the case of your von Neumann and the Harvard architecture in the case is more pins we are using in the Harvard architecture. When you have to assemble any IC, any microprocessor and follow the Harvard architecture in that case, it can NLC they are using the more number of pins as compared to the von Neumann architecture. Now it is widely used, so more difficult to implement as comparison to von Neumann because that is the basic one method. It should be more typical as compared to your von Neumann Harvard architecture is now. Harvard architecture requires a control unit for two buses that is more complicated and development of which is expensive and need more time. So that is some basic concepts, basics difference difference majority between your von Neumann and Harvard architecture is basically वही difference है आपका कि जो हमारा architectural behavior उसका different है. Architectural behavior different कैसे है? Because we are using the single bus, different buses. So that is a majority reason we are using the Harvard architecture in the right now in your different microcontrollers and the processors. So that are the topic I have to discussion about here. That is a Harvard architecture and von Neumann architecture with the different architectures with block diagram, with advantages and disadvantages of von Neumann and Harvard architecture, benefits, advantages and disadvantages of both of them. So that is the topic now.